If you want to learn Java, these concepts will appear everywhere. They are types, strings, equality, lists, maps, and calls. In this video, we will connect them together so you'll understand not only the syntax but also when to use each one. Here's the roadmap. We start with the primitive and reference types, then string and string builder, double equals versus equals. After that, we move into lists, maps, sets, stacks, and calls. First, data types. In Java, the most important mental model is primitive types versus reference types. If you understand this difference, many other topics become much easier. Primitive types store simple values directly. Examples are int, double, boolean, and char. They are fast and simple. When you write int age equals 25, age directly contains that value. Reference types are different. The variable doesn't directly contain the whole object. It points to an object in memory. Strings, arrays, classes, and collections are reference types. This difference matters because primitives and references behave differently, especially when comparing values. This is exactly why double equals and equals can be confusing in Java. Now let's talk about string. Beginners often think string is just a primitive type because it looks simple. But string is actually a class and a reference type. String stores text, but it is an object. That's why we can call methods like length to uppercase and equals. This is also why string comparison needs attention. String is immutable. That means once a string object is created, its text cannot be changed inside the same object. When you concatenate text, Java creates another string. If you need to build text step by step, especially inside loops, use StringBuilder. It changes the same object instead of creating many temporary strings. Now the famous topic, double equals versus equals. This topic becomes clear when we remember primitive versus reference types. For primitive types, double equals compares the actual value. If int a is 10 and int b is 10, a double equals b is true. For objects, double equals asks, are these two references pointing to the same exact object in memory? Two different string objects can contain the same text, but still be different references. Equals usually compares content. With a string, equals compares the actual text. So if two strings both contain Java, equals returns true. The rule is simple. Use double equals for primitive values. Use equals for object content. For string content, equals is the safe choice. Now we move to collections. A collection is a structure for storing multiple values. We start with array, ArrayList, and LinkedList. An array is like fixed boxes next to each other. It is fast when you access by index, but its size is fixed. Use it when you already know the size. So the size must be known by arrays. ArrayList is usually the default list choice in Java. It can grow dynamically, and it is simple to use. Internally, it behaves like a growable array. Internally, it is an array that grows dynamically. LinkedList is a chain of knots. It can be useful for adding and removing at the beginning or end, but random access by index is usually slow. So, here is the practical rule. Use array when the size is fixed. Use ArrayList as your normal default list. Use LinkedList only when the behavior really fits a Q or a Deque style. Next, HashSet and HashMap. These two are extremely important because they solve different problems uniqueness and lookup. HashSet stores unique values. If you add the same email twice, the duplicate is ignored. This is the perfect choice when duplicates are not allowed. HashMap stores key value pairs. For example, student ID 1 points to Omar. You use the key to quickly get the value. The difference is then simple. HashSet checks membership. Do I have this value before? HashMap performs lookup. What value belongs to this key? Now we talk about structures, where the important question is not only what you store, but in which order you remove items. Stack means last in, first out. The last item you add is the first item you remove. Think about it like undo functionality or backtracking. Co means first in, first out. The first item you add is the first item you remove. This is like a waiting line or a task queue. Deque means double-ended queue. You can add and remove from both ends. In modern Java, ArrayDeque is often a clean choice for stack and queue behavior. At this point, the question becomes, how do I choose? The answer depends on what the data means and how you need to access it. Choose the structure by behavior. Single simple value, primitive. Text, string or StringBuilder. Ordered list, ArrayList. Unique values, HashSet. Key value lookup, HashMap. Removal order, stack, queue or deque. Here are common beginner mistakes. Using double equals for string content. Using LinkedList as the default list. Using array when the size must grow. And using list when values must be unique. Quick quiz. Unique emails should be a HashSet. Student ID to a student name should be a HashMap. Undo history can use a stack. Matrix appends should use StringBuilder. Final recap. Primitive versus reference explains many Java behaviors. String is immutable. Use equals for string content. ArrayList for the default list. HashSet means unique values. HashMap means key value. Stack, key, and deque are about removal orders. In the next video, we will continue with Java OOP basics, classes and objects, access modifiers, constructors, this versus super, static, final, interfaces, and overriding.